All right, guys, in this section, we're going to go ahead and teach you guys some AP pre-calculus. And so we've adapted some of these notes from Brian Passwater and some Calcmatic. And I'm going to go through the notes today. We're going to focus on change in tandem. And so on here, it tells us a function is a mathematical relation that maps a set of input values to a set of output values, such that each input value is mapped to exactly one output value. So that's what we define a function as. Something that has one input value for each output value. In previous courses, you may have used the vertical line test to determine if a graph is a function or not. So in Algebra 1, you probably use that quite a bit. However, in AP Pre-Cal, we will use the statement, each input has exactly one output. So when you are defining something as a function or not, that's what you want to say. Each input has exactly one output. When explaining why a given relation is a function, we must connect the inputs and the outputs. Later in this course, we will learn why the vertical line test is not a valid explanation for a function. In Unit 3, we will discover polar functions, and polar graphs often fail the vertical line test, but they are actually functions. So we don't want to say the vertical line test because that's why it's not an accurate test. The next part here tells us the set of input values of a function is called the domain, represented by the independent values. The set of output values of a function is called the range, represented by the dependent variable. Now, vocab is pretty important in AP Pre-Cal, so you want to make sure that you understand what these terms mean, and you're going to have to read them carefully in questions, because some of them can get tricky. So we've got a question here, a graph that's got some parts, and we're going to practice that domain and range. So it says the set of input values, which is the independent variable, is the domain. So we want to look at all of our x values. That's our independent variable. So we're going to start from the left to the right, and we're going to say all of the x values that are found on this graph. In AP Pre-Cal here, we are going to focus on the interval notation. So here we go. This does have an arrow. As it continues down, it's also continuing to the left. So we would start with negative infinity, and that's always a parentheses because that's not an actual number. Now we see that both of these are open circles. So that means it's getting really close to -1, but not touching, so that too is going to be a parentheses. Then it picks back up at that -1, and then we've got all of these x values up to 4. Again, we have a parenthesis because that's an open circle, so there's not an actual point at 4. So we got to skip over that one. Then here it starts at close to 4 and then keeps going forever, so this would be 4 to infinity. Now our range is our dependent variable, and so that's going to be our y values. So we're starting from the bottom going to the top. And so since this has an arrow that's going all the way down, we would say this would start at negative infinity. Again, that's a parentheses because there's no actual point there. And so we've got all of these y values as it goes up to the point of -1. That's an open circle, so we've got a parentheses, and then it starts right here at 2 and goes up forever, so that would be infinity. The reason why I didn't worry about this is because all of these values are at -2. And so that was already included. From negative infinity to -1, -2 is found there. So I didn't have to worry about those. I'm just looking at this graph from the bottom to the top. So negative infinity to -1, then we have no values until we start at this 2 and it goes up forever. So this is what our domain and range would look like in a question that we're answering. All right, the next part tells us that a function f is positive when the graph of f lies above the x-axis, i.e. the outputs, the y values, are greater than 0. So our function f is positive when the graph of f lies above the x-axis. So here's my x-axis. So this part right here would be the positive because it is above the x-axis. It is greater than 0 there. And when we write this down, we write our x values. So we're looking at our y values, but we're writing our x values. All intervals are written down in the x values. So that would be from 4 to infinity. It matches this part of the domain right there. That's my intervals. We're saying this part is above the x-axis. Then for a function f is negative when the graph of f lies below the x-axis, i.e. the outputs. Y values are less than 0. So that would be all of these values here. So it's really going to be the rest of my domain there. Negative infinity to -1 and -1 to 4. Those are the negative values. They're below that x-axis, so the y values there are negative, which is the value of the function. All right, in this course, we are going to look at multiple representations when we do questions. So anytime that we ask a question, it could be given in graphical, analytical, which means in an equation, numerical, which means a table, or a verbal representation. So you're going to have to get used to going through all 4 different representations on questions. To be successful in the AP Pre-Calculus, we need to be able to identify important information from each representation and construct equivalent representations of functions. So moving from the graphical to the table or the table to the graph or any of those forms. Now we're going to do a whole lot of practice in all 4 forms of that, so don't get worried. All right, we're going to look at a problem here and start thinking through that. It tells us the figure shows an empty vase at a time t equals 0. The water begins pouring into the vase at a constant rate until it is full. Which of the following could depict this situation, where time in seconds is the independent variable and height of water in the vase is in inches is the dependent variable? So when we start looking at this vase, we're filling it up. And so right here, it starts to fill up, and it would be here. And then it starts to fill up, and it goes there, and it continues going that way. Now, when we think through that, as the height is going up, our diameter here is different. So when it starts to fill up here, it's filling up at a faster rate than it would at this point right here. So when the diameter is increasing, the height is increasing at a decreasing rate, is what we say. If the diameter is decreasing, then the height would be increasing at an increasing rate. So when we look at these graphs, this is increasing at a constant rate. So our height would not go up at that constant rate because, again, it is smaller here than it is in this section. So when we look at these graphs, we would say this would be the one that represents it because it is increasing a little bit here and then it gets a little constant as we're in this middle section. This is all going to go up the same. So we've got this smoother part right here, and then it starts to increase again as this diameter starts to decrease once again. Then our rate is increasing. All right, so let's talk about that here. Our graphical behavior of functions. It says, as the input values increase, the output values always increase. We call that increasing here. So we're going over increasing, decreasing, concave up, and concave down. Again, there's a lot of vocab in this course, so you're really going to have to focus on those when we're talking. As the input values increase, the output values always increase. That is considered increasing. You can see that it's got a positive slope when it's doing that as well. As the input values increase, the output values always decrease. In this case, we see this is decreasing. We've got that negative slope. So increasing, it is going up from left to right. Decreasing, it is going down from left to right. Our graph will be concave up when the rate of change is increasing. That is different than when our graph is increasing. So these can get tricky if you don't focus. Increasing is when our graph is going up from left to right. Concave up is when that rate of change is increasing. Concave down is when the rate of change is decreasing. So it tells us down here in our notes that before we move ahead, it is important that we clarify a few things about the notation and vocabulary that we will use throughout the course. First, when describing features on a graph, we generally write the intervals where the graph displays those features. We always use the input, the x variable, when writing intervals. This is confusing for some students, so make sure that you focus on that. When we're writing our intervals, we're going to use that input value, the x. All right, it says the figure shows the graph of the piecewise function f over the intervals 0 to 9. What are all the intervals where the graph of f is increasing? So we want to see the ones where it is increasing. We're looking at our graph now, not the rate of change. So we're looking at our graph. Where is this increasing? Well, it would be increasing right here and right here. Those are the two parts where it is increasing. Now, if we wrote our y values, then this portion of the graph would be exactly the same. Sorry, this portion right here would be exactly the same as this one. That's why we don't write the y values, because it doesn't give a clear picture. Now, if I write the x values, I say from here to here, my graph is increasing. And then from this point to this point, it's increasing again. So just by giving the intervals 0 to 3 and 7 to 9, then we've given the values of where the graph is increasing. And without seeing the graph, someone can know where this graph is increasing from 0 to 3. Well, that's this piece of the graph, so I know it's increasing. And then 7 to 9 right here. All right. The second thing that needs to be clarified is the phrase rate of change. This phrase will be utilized repeatedly throughout the course and in AP Calculus, so it's important that we understand its meaning. Essentially, rate of change simply means slope, which you learned in Algebra 1. Anytime we see the phrase rate of change in this course, we can generally replace it with the word slope to help us better comprehend what it's being said. Now, we must be very careful. Stating that f is increasing is very different than stating that the rate of change of f is increasing. These two things are different, so you cannot interchange those. So we're going to look at two graphs so you can see how those comments look the same, but you really need to be careful and think through these. On this graph here, it says f is positive because the output y values are all positive. The graph is above the x-axis. So these are all considered positive because for y, this is 0, and it gets positive this way and negative this way. So all of these values are positive. F, the graph, is positive. Now, f is decreasing because the output y values decrease as the input x values increase. The graph of f goes down as we move to the right. So when we start at the left here, my y value is bigger, and then it's getting smaller and smaller and smaller. So this graph is decreasing. F is decreasing. Now here's that part that you can confuse this with. The rate of change of f is increasing because the graph of f is concave up. So we see this concave up part right here. This is facing upward. This is facing downward. So this is concave up, concave down. And so then we know that the rate of change is increasing. The graph is decreasing, but the rate that it's changing is increasing. Now we already said on this one here, it is concave down, so the rate of change is decreasing. This graph here, G, is increasing because as I go from the left to the right, my y values are getting bigger as my x values are also getting bigger. And then G is a negative graph because it is all under the x-axis. Again, this is 0. As it goes up, this is positive. As it goes down, this is negative. So my graph G is negative. All right, so let's look at an example here and see if we can come up with the parts ourselves. So this is asking for where is the graph positive? So we want all of the values above 0. So that would be this part right here. Right here, it is 0. It is negative here. It is negative here. All of this part is positive. So we want all of these values. Well, this starts right here at -4 and it goes till -1. So I would say -4 to -1. We want to include -4, so I'm going to put a bracket there. That means -4 is included in the points that are positive. Now, -1, at -1, that point right there is -1, 0. So my function is 0. It is not positive there. It is 0, so I want a parentheses. I do not want to include that point. All right, for the negative part, all of this is negative except right here, it's 0 again. Right there and right there, it is 0. So we do not want to include those points. So I would say from -1 to +1 with a parenthesis. This means not included. We are skipping over 1. And then from 1 to 3. And 3 I do want to include, since it is negative right there. See that graph? -1. My function is -1 there. So in these two intervals, it is negative. That's all of these points. We skip over this one, and then all of these points are negative. All right, for increasing, this part of the graph is increasing, and so is this part. It's negative there, but it's going from that -1 value up to 0. So this is increasing right here. So I would want both of those values. All right, so from -4 to -2, it's increasing. And then from 0 to 1, it's increasing. For decreasing, this is decreasing. And then this is decreasing. So we've got two different parts that are decreasing there. It starts to decrease at -2. From right up here. And then it stops right here at 0. Again, it's those x values. And then it starts to decrease again from 1 to 3. All of these, we're listing the x values because we want to say this portion of the graph. This portion of the graph. We look at the y values, we write the x values. All right, so for concave up, this is the part that's concave. And so this would be from -1 to 1. This part is concave up, it's opening upward. And then it's never concave down. So this would be none. All right, now we're going to look at some of the questions that you would see on an AP exam and talk about what they mean. This first part says the graph of h of t and its dashed midline for 2 full cycles is shown. 5 points F, G, J, K, and P are labeled on the graph. No scale is indicated and no axes are presented. The t-coordinate of F is T1 and the t-coordinate of G is T2. All right, so the first thing I want to do here is I want to think about the 2 points they're talking about. So that's these 2 points right there. I'm going to circle them so that I can be aware of what I'm looking at. The first question says on the interval from T1 to T2, so from here to here, which of the following is true about H? It says H is positive and increasing. All right, let's think about that. 4 is positive. 0 is not. But then I know that this has to be the x-axis by looking at that. Since this value is 0 and this value is 0, then I need to know that this is the x-axis when I'm studying this graph. This is also going down. It is decreasing. As I move from left to right, it is decreasing. So I know it is not increasing and not increasing, so I can knock both of these out. This says increasing, this says increasing, so I take those out. So it's got to be one of these two right here. My two choices is positive or negative. This is from 0 to 4, so that would be positive, so B would be the correct answer. All right, let's try another one here. And I'll give you a second to read through it and try it if you want to go ahead and pause the video. Oh, sorry, we missed a part here. Just kidding, 1 second. This part right here. Describe how the rate of change of H is changing on the interval T1 to T2. So we would answer this as the rate of change of H is decreasing because, and so let's look at it. It's this portion right here that we're looking at it. We know that the average rate of change is decreasing because it is concave down on that portion of the graph. So remember when we were talking about concave up and concave down describes what the rate of change is doing. So the rate of change of H is decreasing because it is concave down. All right, so go ahead and pause it and try this problem here. It's very similar to that one up on top. All right, so here's what you should have gotten. H is negative and decreasing. And we know that, again, because you circled the 2 points that it's talking about. We can see that it's increasing as it moves from left to right. And so you can take out the two problems that say decreasing. And then your difference is positive or negative. Well, looking at these values, this is -4 and this is -1. So I know both of those points fall under the x-axis. So I know it is negative. And then this one too was concave down. So our rate of change is decreasing. All right, we're going to finish a couple last questions where we're going to look at some graphs again and talk about what's happening. It says the figure shows the graph of the function f on the interval -5 to 5. On what intervals is f decreasing? So we look at our graph as we move from left to right. This is increasing. Right at this point, it starts to decrease. So we're talking about this part of the graph. Then it starts to increase again as we go left to right. When you're writing these intervals, you are writing the x values. So from here to here, that's the part of the graph that is decreasing. Y values repeat, x values do not. So we want to write the x values. Look at the y values, write the x values. So from -1 to 2 is where the graph is decreasing. The next part says, on what intervals is f both negative and increasing? All right, so we said these two parts are where it's increasing. Now, all of this occurs above the x-axis, so that's positive, and this part is above the x-axis. So the only part we're talking about here is this part right here. And so this would be from -5 to -3, and I do not want to include -3 because it is at 0 there. That point right here is -3, 0. So it is not positive or negative. It is 0. All right, we'll look at one last graph before we call it a day today on change of tandem. The figure shows the graph of the function g on the interval -5 to 5. Point A is located at -1, 0. So this point right here. And is the only point where the graph of g changes concavity. So this part here is concave down, this part is concave up, is what that's telling us. On what intervals is g decreasing and the graph of g concave up? So we just said this is concave down, this is concave up. So we want to know where it is decreasing and concave up. Well, it would be decreasing right here until it gets to this point. Then our graph starts to increase. So we want to say from that A value to 1 here. So that would be -1 to 1 is where it is decreasing and concave up. All right, for number 8, it says on what intervals is the rate of change of G positive and decreasing? So now we're talking about that rate of change. And we want to know where it is positive and where it's decreasing. Well, we said it's decreasing when it's concave down. So our rate of change is decreasing on these values right here. And we want to know where it is positive and decreasing. And so that would be from -5 to -3. All right, so that was change in tandem, sorry. We are done with our first lesson in AP Pre-Cal.